In this video, we'll be discussing polynomial functions and how to identify and classify polynomial functions. So first, let's discuss what a polynomial is. A polynomial is the combination of adding or subtracting algebraic expressions. So for example, 3x to the fourth plus 7x squared minus 5 is a polynomial function because it has algebraic expressions that are added or subtracted together. Now, in order for an expression to be for an expression to work in a polynomial, the exponent must be a whole number. The exponent, all exponents, must be whole numbers. Now, in the past, we've discussed what whole numbers are, which would be 0, 1, 2, 3, 4, 5, and so on. So as long as the exponents in the polynomial are whole numbers, then it is a polynomial. So the reason this is not a polynomial function is because it has a variable in the denominator, which means it is technically an exponent of a -1. And so therefore, this is not a polynomial. Again, the exponents must be whole numbers, which is 0 and then all natural numbers. Now, the standard form of a polynomial is written in descending order by degree. So if you notice that the degrees, all the exponents are in descending order, and then the constant is at the end because technically that would be 1 times x to the 0 power because x to the 0 is the number 1. Now, the degree of a polynomial is the highest exponent of the entire polynomial. So the degree of this polynomial is 4 because it is the highest exponent. The coefficient of a polynomial is the number that is in front of a variable. So for example, 5x to the fourth, the coefficient would be 5. If I had 6x to the 10th, then the coefficient would be 6. The leading coefficient is slightly different than coefficients in the fact that it is specifically the number that is in front of the highest degree. So again, in this polynomial, we look at the highest degree, which is a 4, and then we look at the coefficient of that, which is the number 3. Now, you can also classify polynomials according to degree and then according to the number of terms. So first, we're going to discuss according to the degree. If the highest exponent has a degree of 0, meaning x to the 0, then the name is a constant because the x to the 0 is actually a number, and so it would be a constant. If the highest exponent is a 1, for example, x to the 1 plus 2, or in this case, x plus 3, it is called a linear function. If the degree is 2, meaning the highest exponent is a 2, then it is called a quadratic. If the highest exponent is a 3, it is a cubic. If the highest exponent is a 4, it is a quartic, and the highest exponent is a 5 is a quintic. Now, that is according to the degree, again, of the highest exponent. Now, you can also classify polynomials according to the number of terms. So, if there's only one term in the polynomial, then it is called a monomial. So, for example, 6, there's only one term, so it is a monomial. In this case, you have a term here and you have a term here. Since there are 2 terms, it is called a binomial. In this case, we are back down to one term. Again, the terms does not have anything to do with the exponents. The term is how many algebraic expressions are added or subtracted together. There's only one algebraic expression here. That's why it's a monomial. Here, there's 2 algebraic expressions, so it's a binomial. Here, again, there's only one algebraic expression, which is why we say it's a monomial. Here, there are 3 terms or 3 algebraic expressions, and so we call it a trinomial. Again, here we have an algebraic expression and another algebraic expression. There's 2 of them, so it's called a binomial. Anything over a 3 term, we actually just use the generic term of polynomial. So in this case, we are going to name this according to the degree and then according to number of terms. So first, the degree. Look at the highest degree. It is a 4, which means we would call it a quartic. And then, according to the number of terms, there's 1, 2, 3 terms. 3 terms is called a trinomial. So we can classify this polynomial as saying it is a quartic trinomial. Now in this case, again, let's look at the highest degree, which is a 3, and a 3 is called a cubic. And then look at terms. There's one term here and another term here, so there's 2 terms. Go to the number of terms, and it is a binomial. So we would classify this as a cubic binomial. So now let's do a little bit of practice of classifying using the vocabulary of polynomials. Beginning with this expression, we want to know, is this a polynomial or not? So if you look at the exponents, this exponent has a negative with it, and so therefore automatically this does not represent a polynomial. If you look at this expression, we have a p squared, okay, that is an algebraic expression. Now we have p to the negative 5. Again, because it is a negative exponent, it is not a polynomial. Okay, let's look at this one. We have s to the 2nd power, we have s to the 5th power, and s to the 4th power. So we want to know, are these exponents all whole numbers? Yes, they are. So it does represent a polynomial. So now we are going to call this what? What specific type of polynomial is it? So how many terms are there? There's 1, 2, 3 terms. So we call it a trinomial. And then we look at the highest degree, which is a 5. So it is a degree of 5. Now, with polynomial operations, we can also go ahead and add, subtract, multiply, and divide with polynomials. So in this case, in order to simplify this, we are first going to distribute the negative 7 to every term in the second parentheses. So we have a 5x cubed minus 6x squared plus 1. And now we have negative 7 times x to the 3rd is a negative 7x to the 3rd. We have negative 7 times negative 2. The two negatives turn to a positive 14 x squared. And the negative 7 times x is a negative 7x. So now we need to look for anything that has in common. So we have a 5x cubed and a negative 7x cubed. That will give us a negative 2x cubed. And then I notice that we have a negative 6x squared and a positive 14x squared. Negative 6 and a positive 14 will give me a positive 8x squared. There is only one term that has a x in it, so I'm just going to bring down the negative 7x. And then only have one term that has a constant, so I'm going to bring down my constant. And that would be the final answer in standard form because they are descending. If you notice the exponents do descend, that will be our final answer of our polynomial operation. In this case, in order to simplify, we're going to need to first multiply. So I'm going to multiply x times 2x first to give me 2x squared. And now I'm going to multiply that by the next parentheses, which is 4x plus 1. So 2x squared times 4x will give me an 8x cubed, because 2 times 4 is 8, and x squared times x is x cubed. And now 2x squared times 1 would give me a 2x squared, and that would be our final answer. Do not add x cubed plus x squared to give you x to the 5th. You cannot add exponents that have different, you cannot add terms that have different exponents. So x to the 3rd plus x to the 3rd would actually give us 2x to the 3rd because there are 2 terms with x to the 3rd. It does not give you x to the 6th, so be very, very careful about that. Only exponents that have the same, only terms that have the same exponent can be added. So x cubed plus x squared, you cannot do anything with. It is not x to the 5th. Do not add different exponents together. Now in this case, to simplify, this 3 does not mean that. Do not do that. Do not do that. Do not do that. Do not. Did you hear me? Do not do that. X minus 2 cubed actually means that you write the expression x minus 2, you actually write it 3 times. And now you have to FOIL. So I'm going to FOIL the first two first. So I'll get x squared minus 2x plus 4, because negative 2 times negative 2 gives you a positive 4. This gives you x squared minus 4x plus 4. And I now will multiply that by my third x minus 2. So I will get x squared times x, which is x cubed. X squared times negative 2 is a negative 2x squared. Negative 4x times x is a negative 4x squared, because x times x is x squared. Negative 4x times negative 2 is a positive 8x, because negative times a negative is a positive. And then 4 times x is 4x, and 4 times negative 2 is negative 8. Now you need to combine like terms. There's only one x cubed, so I'm just going to write it over here. I have two x squares. I have negative 2 here, and I have negative 4 here, so I have negative 6 total. And then I have 8x and 4x combined to give me 12x. Remember, you're only adding the coefficients. Do not say that x plus x is x squared. Please don't do that. Just add the coefficients. And the negative 8 is the only constant. And there would be your answer. So, in order to write an expression that equals 3d minus c, we know that this is what d equals, and then this is what c equals. So we are going to multiply 3 times this expression. So 3 times d, and then minus c. So d is 2 minus 9 n squared is n plus 3 plus 4n squared. So 3 times 2 is 6. 3 times 9 is a negative 27n squared. And then I'm going to distribute this negative. So that will give me a negative n. That will give me a negative 3. And then negative times 4n squared will give me a negative 4n squared. Now you need to combine like terms. Negative 27n squared and a negative 4n squared will give me a negative 31n squared. Negative n is my only term that has an n. And then I have a 6 and a negative 3, which will give me a positive 3. And that would be my final answer in this polynomial operation. So let's recap. Classify by its degree and number of terms. So first, look at the highest term. It is a 4, which means we know that it is going to be a quartic. We also know that there's 2 terms. And so 2 terms means that it will be a binomial. Now, to simplify this, we need to distribute the negative 3 to this entire parentheses. So this will give me a negative 6x cubed. Negative 3 times that will give me a negative 3x squared. Negative 3 times x will give me a negative 3x. And negative 3 times negative 5 will give me a positive 15. And now I'm going to combine this polynomial with the original. We have a negative x cubed and we have a negative 6x cubed. That will give us a negative 7x cubed. We have 4x squared and we have a negative 3x squared. That would give us a positive 1x squared, or you can just say x squared. You don't have to say the 1. We have a negative 3x. We don't have an x over here, so this negative 3x will go next. And then we have a negative 1 and a positive 15, which will give us a 14. And last, to simplify this square does not mean that you just square this term and square this term. It means that you need to actually write out the expression twice. So when you FOIL, you'll get x to the 4th plus 5x squared plus another 5x squared plus 25, which will give you x to the 4th plus 10x squared plus 25. And then we're going to combine that with 2, distribute the 2, and we'll get 2x squared minus 16. Now we can combine like terms. This x to the 4th is our only x to the 4th. This 10x squared plus this 2x squared will give us a 12x squared. Again, do not combine x squared and x squared to give you x to the fourth. You just add the coefficients in front, 10 and 2. And then 25 and a negative 16 will give me a positive 9. And that is your final answer.